Now, writing the molecular formulae of organic compounds. Let me spell this correctly. Writing the molecular formulae of organic compounds. The first question here is 2-methyl-2-hydroxypropane. In 2-methyl-2-hydroxypropane, first thing you should take note of is that your main skeleton, the main skeleton of the compound is the propane. All of these, a hydroxy attached on the second carbon atom. All of these are attachments, a methyl attached on the second carbon atom. So when I draw the structure, I'm going to draw a propane skeleton. That's 3 carbon atoms for propane. If I draw a propane skeleton, I'll now attach a methyl group on the second carbon atom and another methyl group on the second carbon atom also. So whichever way you name this, either you name it 1, 2, 3 at the top like this, 1, 2, 3, or you name it 1, 2, 3 at the bottom like this. It all means the same thing. So that's the molecular formula of the compound. 2-methyl-2-hydroxypropane. So the next question is B. 2-methyl-propan-2-ol. Here to take note, propan-2-ol is CCC with a hydroxy group on the second carbon atom. That's propan-2-ol. What is showing in blue here is your propan-2-ol. But the question says there's a methyl group attached to the second carbon atom. So I'll just attach CH3. So this compound is 2-methyl-propan-2-ol. Essentially, it's the same as 2-methyl-2-hydroxypropane. Question C, propanoic acid. In propanoic acid, you should take note that this is an alkanoic acid, so it will contain the carboxylic acid group, COOH. Now, to this carboxylic acid group, counting from the first carbon atom here, counting this as the first carbon atom, this as the second, this as the third, you will have 3 carbon atoms forming a chain. So there must be 2 extra added to it, CH2, CH3, to make it prop and to make it propanoic acid. Take note of that. The fourth one is D, methyl ethanoate. Methyl ethanoate. Methyl ethanoate. In methyl ethanoate, you should take note of the main compound. The main compound is the ethanoate ion. The ethanoate ion is formed from ethanoic acid. Ethanoic acid will be COOH, then 1 carbon atom to make it, ethanoic acid. So this is ethanoic acid. But when it ionizes to give off its hydrogen, it now becomes the ethanoate ion. So this is the ethanoate ion. You understand? Ethanoic acid ionizes to give this ion negatively charged and H+. You understand? Originally, this is ethanoic acid. But when it dissociates in solution to release the hydrogen ion as the only positive ion, being the behavior of an acid, it produces ethanoate ion. This is ethanoate ion here. So with all of this described, methyl ethanoate now is methyl group attached here to the ethanoate ion. So all I need to do is just attach a methyl. That's the molecular formula of my compound. But this is more of a structural formula. So molecular formula will be, starting from the left, CH3, COOCH3. So more correctly, I should write the molecular formula as CH3, COOCH3. That's methyl ethanoate, methyl, then ethanoate. So that's the molecular formula of the compound. Let's go to E. In E, the question is very simple. It's methyl propanoate. Never mind my handwriting there. methylpropanoate. So this is 1Y. Take note. Let me clean it and rewrite. Methylpropanoate. So here too, all I need is to identify the main part of the compound. The main part of the compound is the propanoate from propanoic acid. Propanoic acid, like we did in the previous example, is CH3CH3OH. This is propanoic acid. But when it dissociates to give off this hydrogen, I'm coming. This is propanoic acid. But it can dissociate to give off this hydrogen and form propanoate ion. This is propanoate ion and hydrogen ion here. So this is, minus this. If you were to put the two together, this is propanoic acid with the H. But an acid dissociates in solution to give off hydrogen ion as the only positive ion. So it will form propanoate ion and hydrogen ion. So it is this propanoate ion that methyl gets attached to form methylpropanoate. Can you see the understanding? So the molecular formula of the compound is CH3 CH2 COOCH3 CH3CH2 COOCH3. This is methylpropanoate here. Let's go to the next question. That's F. 3-methylpentene. F is 3-methylpentene. 3-methylpentene is first thing, let's identify the main backbone of the compound. The main backbone of the compound is pentene. The main backbone of the compound is what? Pentene. So you check this very well. You see that's what the main backbone of the compound is. Pentene is C. This is pentene. You understand? Okay, no. Pentene is 5 carbon atoms. 1, 2, 3, 4, 5. So, since the position of the double bond, the double bond that makes it an alkene, the position is not stated or it's not indicated from the name of the compound. If it had been pent 2 in, we'll put it here. If it had been pent 1 in, we'll put it here. But we are not told, so let's just put it here. So counting from here, this will be 1, 2, 3, 4, 5. So 3-methyl will be here. CH3. That's 3-methylpentene. We now complete the remaining bonds with hydrogen. We complete the remaining bonds with what? Hydrogen. That's 3-methylpentene. So if I'm writing molecular formula now, it will be CH3, CH2, CH3, then CH2. So this is 3-methylpentene. So more correctly, I should keep this in bracket to indicate that it's an attachment. That makes the compound clearer. Let me write it more clearly. CH3CH2, CH3CH2, CH3, CH2. So take note of that example. Then G, let's go to G. G is 2-hydroxy propanoic acid. So first thing here is to identify that This is a propanoic acid. The rest are just stories. This is the compound we are looking at majorly. So all of the rest here, 2-hydroxyl, it's just an attachment, so to speak. So let's draw propanoic acid, COOH, C. That makes it 3 carbon atoms to form propanoic acid. The rest will be hydrogen. So the bond of each carbon is complete now. 4 for this, 2, 1, 1. That's 4 for this carbon. 2, 3, 4. 4 for this carbon too. 1, 2, 3, 4. For this carbon too, 4. 1, 2, 3, 4 bonds. So 2-hydroxy means there's an hydroxy group on the second carbon atom, because this is always called the first carbon atom. This is the second, this is the third. So we number it this way. 1. Let me make that clear. 1, 2, 3. The carbon carrying the carboxylic group is always, labeled the first carbon atom, or carbon 1. This is carbon 2, this is carbon 3. So 2-hydroxy means there's a hydroxy group attached to the second carbon atom in the compound. So let me clean away this one. So I just add hydrogen to the rest. H. So my compound is CH3, CHOH, COOH. That's the molecular formula of 2-hydroxy propanoic acid.